Hello and welcome back to San Diego Earthquake Watch. My name is Ryan Dargar. Today, after the effects of last week's earthquake, we will be delving deeper into the subject, earthquakes. Also, special guest Dr. Jason Gall will be joining us here today.
Thank you, Ryan. My name is Jason Gall, and in this broadcast, we'll be covering the earthquake we just had recently, actually in the last report.
Let's give it over to our reporters in the field, who are near the recent wreckage of the area.
But first,
commercial break.
How it feels to chew 5 gum. Stimulate your senses.
Thanks, Ryan. As you can see, the earthquake seems to have shaken things up here. The road has been cracked from the shaking of the earthquake.
we know that the earthquake was a 7.0 magnitude earthquake, certainly capable of messing things up here. Back to you, Jason. Thank you, Jason.
Now let's get into the science behind earthquakes. Earthquakes happen when the tectonic plates suddenly move and release energy. When the energy travels through rock, it causes the ground to shake.
That is correct, Ryan. An earthquake can happen at any of the 3 boundaries. Earthquakes occur at divergent boundaries when tectonic plates pull apart. When they pull apart, tension breaks the lithosphere into fault blocks. Earthquake happens when the normal faults move.
Earthquakes happen at convergent boundaries when tectonic plates collide. When they do, they either form a mountain or one subducts under the other. During either one, compression breaks the lithosphere into fault blocks. Earthquakes happen when the reverse faults move.
Earthquakes happen at transform boundaries when the tectonic plates move past one another. When they move past each other, it causes earthquakes along strike-slip faults.
Now let's take it over to Dr. Dargar, along with a seismologist from the U.S. Geological Survey, or USGS.
Yay.
Thanks, Ron, and it's a pleasure to be back on the show. I would like to introduce you to my good friend, Mr. Jason Gall, a seismologist from the USGS, or the U.S. Geological Survey. He studies earthquakes and seismic waves.
Thanks. As Dr. Dargar said, I research for USGS. I focus on seismic waves. Seismic waves are the waves of energy caused by the sudden breaking of rock within the surface of the Earth. They are the energy that travels through the Earth and are recorded on seismograms. A seismograph measures the records details of earthquakes, such as the force and duration. It does this on a seismometer. It really is a pleasure on here talking to you about earthquakes.
Earthquakes are measured on the moment magnitude scale, aka the Richter scale. The Richter scale operates by increasing by powers of 10. A 1 magnitude to a 2 magnitude is 10 times higher. However, and a 1 to a 3 is 100 times higher. Many earthquakes happen per year, about 500,000. However, only 100,000 can be felt, and only 100 cause damage. The reason why we can't feel some earthquakes is because they are low magnitude. The typical strength of minor earthquakes that we can feel are 3.5 to 4.5.
Earthquakes that are most vicious are the shallow and strong earthquakes that happen on subduction boundaries. When one plate goes above, the other goes down viciously. Back to you, Dr. Gall. When earthquakes occur underwater, they can cause massive waves called tsunamis. Tsunamis usually occur at subduction zones along with earthquakes.
When the earthquake hits the ocean, seismic waves occur, going at 970 kilometers per hour, which is triple the top speed of the fastest car in the world. That is fast. When it moves to the harbor, the tsunami takes form, as the seismic waves don't have enough room to continue at full stride.
The record for the biggest tsunami ever was in Latoya Bay, Alaska, with a wave of 1,720 feet tall. That's about the size of the tallest building in New York. It is the largest ever recorded tsunami. It takes a 7.5 magnitude earthquake to cause a massive tsunami.
In 2011, a Tohoku earthquake under the sea greatly affected Japan, killing over 15,000 people and injuring 215,000 more. Along with that, 2,500 were reported missing.
Earthquakes can cause many things. Volcanoes can also be made by earthquakes. When magma exerts pressures on the rocks beneath the volcano, the rock cracks, making small earthquakes. When it cracks, the magma squeezes through, causing a volcano.
Thanks, Dr. Gao. Earthquake waves are called seismic waves. Seismic waves are classed into subgroups of body waves and surface waves. The first kind of body wave is the P wave, or the primary wave. This is the fastest kind of seismic wave, and consequently, the first two arrive at the seismic station. The P wave can move through solid rock and fluids, like water or the liquid layers of the earth. It pushes and pulls the rock like sound waves push and pull the air. Have you ever heard a big clap of thunder and heard the windows rattle at the same time? The windows rattle because the sound waves were pushing and pulling on the window, much like P waves push and pull in rock. Sometimes animals can hear P waves of an earthquake. Dogs, for instance, commonly begin barking hysterically just before an earthquake hits, or more specifically, before the surface waves arrive. Usually people can only feel the bump and rattle of these waves.
P waves are also known as the compressional waves because of the pushing and pulling they do. Subjected to a P wave, particles move in the same direction that the wave is moving in, which is the direction that the energy is traveling in, and is sometimes called the direction of wave propaganda. The second type of body wave is the S, or secondary wave, which is the second wave you feel in an earthquake. An S wave is slower than a P wave, and it's only to move through solid rock, not liquid. It is this that led the seismologists to conclude that the Earth's outer core was a liquid. S waves move rock particles up and down, or to side perpendicular to the direction that the wave is traveling in. There's also surface waves, traveling only through the crust. Surface waves are the lower frequency than body waves and are easily distinguished on a seismogram as a result. Though they arrive after the body waves, the surface waves that are almost entirely responsible for the damage and destruction associated with earthquakes. The damage and the strength of the surface waves are reduced in deeper earthquakes.
One type of surface wave is the Rayleigh wave, named for Lord Rayleigh, who mathematically predicted the existence of this type of wave in 1885. A Rayleigh wave rolls along the ground, just like a wave rolls along the sea. Because it rolls, it moves the ground up and down, and side to side, in the same direction that the wave is moving. Most of the shaking felt from an earthquake is due to the Rayleigh wave, which can be much larger than the other waves.
Yay.
Well, thank you for watching this edition of San Diego Earthquake Watch. I'm Ryan Duragar.
And I'm Jason Gao.
Give a great thanks to Ryan Duragar, our favorite local earthquake specialist.
And give a great thanks to Jason Gao, our local specialist at USGS, worker of seismology.
Also give a thanks to our field reporters, Ryan Duragar.
And our reporter, Jason Gao.
Be sure to tune in for next time.
This has been San Diego Earthquake Watch, signing out. Yay.